All right, this is 7th grade, Module 4, Lesson 2, part of a whole as a percent. So we're going to continue working with our percents today, and we're going to actually start solving some of them. So you want to have that calculator handy because it will come into help us a little bit here. All right, so find the whole unit of each scenario. All right, so we're not really solving here. You have to kind of decode which one of these numbers is the whole. 15 is what percent of 90? Well, I'm going to give you a clue. Whenever you see the word of before a number, that's going to be your whole because that's the total. So if it's of 90, that's your total of 90. 15 is just the part. So what's the whole unit here? It's going to be 90. What number is 10% of 56? All right, well, 56 is definitely our whole there because that is our total amount. 90% of a number is 180. Now, if you look at it, it says of a number. We don't know what that number is. So when we don't know what something is, we represent it by a variable. So we're going to represent it by the variable x. A bag of candy contains 300 pieces and 25% of the pieces in the bag are red. So if the bag contains 300 pieces, that's our total. So that's our whole unit. 70% of the students earned a B on the test. So 70% of the students. Well, of the students who got a B, that would be all the students who got a B. So we'll just say all students. All 70%. The 20 girls in the class represented 55% of the class. So 20 girls represented the 55% of all the students in the class, so it's all 20 girls or all students. So we take all the students in the class, 20 of them is 55%, take all the students in the class, 70% of them got a B. So you don't really know the number, but you do know it's going to be of all the students that were represented. All right, let's look at B. Read each problem and complete the table and record what you know. So we're looking for the part, the percent, and the whole, okay? We're not solving. Again, we're going to kind of decode. 40% of the students on the field trip love the museum. If there are 20 students on the field trip, how many love the museum? All right, so the easiest one to look for is the percent because that's obviously going to be the one with the percent symbol. So we saw here that we had 40%, so that is our percentage. Okay, do we have a total? Yes, there are 20 students, so that's our whole. So what am I solving for? How many of them? So I'm solving for my part. 40% of the students on the field trip love the museum. If 20% love the museum, if 20 students love the museum, how many were on the field trip? Okay, so again, the easiest one to decode here is the percentage. So we're going to go ahead and write 40%. If 20 students, I keep wanting to say 20%. If 20 students, well, there's your part of the students love the museum. How many actually went on the trip? That's our unknown. Our unknown is the whole on this one. 20 students on the field trip love the museum. If there are 40 students on the field trip, what is the percent? Well, that's an easy one. Look right there. What percent? So there's your X right there. 20 will be your part and 40 is your whole because that's your whole number of students in the class. All right, let's go on to the next one. In Ty's math class, 20% of the students earned an A on the test. If there are 30 students in the class, how many of them got an A? All right, well, let's check it out. So we do know there are 20% of the students got an A, so 20 out of 30. So there's 30 students in the class, 20% of them. So what I like to do is you take your total, and we're going to multiply it by the decimal version of 20%. If you remember from the last lesson, 20% is going to be 20 over 100. And then the decimal version of that, since there are 2 zeros, I'm going to teach you a way to do this without having to use a calculator. Since there are 2 zeros, that's 2 placeholders. So I'm going to move the decimal back 2 placeholders. So it'll be 0.20. So as long as you have a 2-digit percent number, it's always going to be decimal and then the number they gave you. So if I multiply those together, now you might want to use your calculator. So we're going to say 30 times decimal 20, and I get 6. So 6 students got an A. All right, exercise 1. In Ty's art class, 12% of the Flag Day art projects received a perfect score. There are 25 art projects turned in by Ty's class. How many of the art projects earned the perfect score? So basically, we're identifying the whole. All right, so we do know there was a total of 25 projects turned in, and 12% of them, so if you remember from up above here, it's a 2-digit percent, so you just put a decimal and then the number itself, okay, just so you don't have to keep moving your decimals. Just always know 2 digits moves it 2 spots. If I multiply those 2 together, so I'm going to come over here and say 25 times decimal 12, and I get 3. So 3 of the projects received a perfect score. And that's it. That's as simple as it gets. All right, let's move down to the next one. All right, example 2. In Ty's English class, 70% of the students completed an essay by the due date. There are 30 students in Ty's English class. How many completed the essay by its due date? All right. So I do know there are 30 students in the class. So there's my total. All right. And I do know it's 70%. So you remember, I'll just put it over here, 70%, 2 digits. So you just make it 0.70. We'll multiply that by 0.70. Okay. You can grab your calculator. And we'll say 30 times 0.70, and I get 21. So 21 students were able to get their essay in on time. Example 3, an algebraic approach to finding a part given the percent of the whole. A bag of candy contains 300 pieces, of which 28% are red. How many pieces are red? All right, so that's the ultimate question where they kind of broke it down here for us to kind of help guide us through the question. Which quantity represents the whole? Well, there's 300 pieces, so the 300 represents the whole. Which of the terms in the percent equation is unknown? So define a letter or a variable to represent the unknown quantity. So we'll use X as our variable. Again, you could pick anything. You could put R for how many are red. Write an expression using the percent and the whole to represent the number of pieces of candy. So I do know there are 300 pieces, and I'm going to multiply by its percent, 28%. I'm going to make that into a decimal version, and that will give me how many are red. There's my variable coming back in. All right, write and solve the equation of the unknown. So now I will solve it. So I'm going to say 300 times 0.28, and I get 84. So it is 84 pieces are red. And that's it. All right, let's move on to the next one. A bag of candy contains 300 pieces and 28% are red. How many are not red? All right. So this one here says write an equation to represent the number of pieces that are not red. So I do know there are 300 pieces. And I do know that I need to multiply that by 0.28 again. All right. Now, since I solved this down below on the other question, I do know that the answer here is 84. So far, 84 are red. So now using your number, find out how many are not red. So in order to find that, I'm just going to subtract. You have your whole of 300 pieces of candy. If you remove all the red candies from the bag, you'll be left with the total number of candies that are not red, which in this case is 216 are not red. Now over here, I guess you could put these are the red ones, so you can understand the two different answers. Jali told his math teacher that he could use the answer from example 3 and mental math to find the number of pieces that are not red. Explain what Jali meant. So what he was saying is he could have done this all in his head because he had already found that 84 of them were red. Then he just knew that all he had to do was subtract from 300 to find out the number that was obviously remaining of the other colors. So for this one, we'll put, he knew that he could use the answer of 84 to then find the rest of the colors, basically, by subtracting 84 from 300. So yes, you could have done mental math on that one in the event that you understood how to find the remaining pieces. All right, let's look at example 4. I'm going to scroll this up real quick because I can see that I'm going to need some workspace. Zoe inflated 24 balloons for decorations at her middle school dance. If Zoe inflated 15% of the total of number of balloons inflated at the dance, how many balloons are there total? Solve the problem using the percent formula and verify your answer with a visual model. All right. My visual model will actually be setting up proportions, and that way you can kind of see where everything goes. So I like to use this proportional relationship formula is over of equals your percent over your 100. Your percent number over 100, these are always going to be present. Now this here is your part. So this is your part of a whole. And I use the word of because if you remember in the few questions back, I said if you see the word of, that's going to be your total amount. All right, so in this case, we have 24 balloons were blown up by Zoe. That's part. It didn't say that was the total. It just said she inflated 24 balloons. All right, so I'm going to set this up. The 100 is always there. That one never changes. Oh, I see a percent symbol. So there's instantly my percent number. So obviously I'm solving for my of. I'm solving for my total, which makes sense because it says how many balloons were there total. So that's going to be my x. All right, now what I'm going to do is I'm going to cross multiply. I always like to do my x first. So 15 times x is going to give me 15x. 24 times 100 is going to give me 2400. Now I want that x by itself. So I'm going to divide out that 15. And what you do to one side, you have to do the other. My 15s cancel because they become one whole. And I'm going to come over here and do 2400 divided by 15. And I get 160. So there were a total of 160 balloons at the dance. Oh, that's the total of numbers that still need to be inflated. I apologize. So 160 balloons still needed to be inflated. We'll put the word to there. All right, there you go. Let's move on to the next one. Hallie is making admission tickets to the middle school dance. So far, she has made 112 tickets, and her plan is to make 320 tickets. What percent of the admission tickets has Hallie produced so far? Solve the problem using the percent formula and verify with your visual model. All right, so again, my visual model will be actually just setting it up as a proportion. So if you remember from the question before, our formula is going to be is over of, part over whole, equals our percent over 100. That 100 is always there. So far she's made 112. Okay. What is her total number she wants to make? 320. And we're going to set that equal to 100s down here. Do I have any number here that has a percent symbol next to it? No. And in fact, it says, what is the percent? Oh, where is it? What percent? Wrong percent word. What percent? So there's my x. All right, so now we're going to cross multiply. I like to do the x first. So 320 times x gives me 320x. And 112 times 100 gives me 11,200. And again, I want to divide out that 320 to get the x by itself. So those cancel. All right. Now, this is where you probably want your calculator. We're going to do 11,200, and we're going to divide that by 320, and I get 35. So 35%. Don't forget your percent symbol, because what was I solving for? I was solving for percent of the ticket. So far, she's done 35% of her goal to getting all the tickets completed. All right, and that is the end of this lesson, and I hope the video helps.